Our next property is power of a power. And the property states that b to the m, all to the n, equals b to the mn. When you see this, you can definitely see why it's called power of a power, because here's a power and it goes to another power. When you break it down, you keep the base the same. So I had a base of b, so I keep it b, and then I multiply the exponents, m times n, and that's why it was smushed together, meaning multiply. So if I follow the rules, it says keep the base the same. So I have 3 to the 8th, all to the 4th power. Keep the base the same, which is 3, and then I multiply 8 times 4, which is 32. 3 to the 32nd power. Just leave it as that. We don't need to do anything more with it. And of course, this is algebra, so let's pull in some variables. Keep the base the same, m, and you multiply 2 times 5, which is 10. So keep the base the same, multiply the exponents, a power of power. A complete explanation of how this works is in my complete notes that is in the extra support row of your grid. All right, so let's take it up a notch. Here we have 2g times g to the 3rd all to the 9th. This is actually a combination of power of a power right here and product of a power. So if I rewrote this, this would be 2g times g to the 3rd all to the 9th. So I'm going to do power of a power first. So I keep the base the same, g, and I multiply 3 times 9, which is 27. And then I'm going to multiply that by the 2g. Now, your first job to multiply is just to multiply the coefficients. And if there's nothing there, I can put in a 1. So I have 2 times 1, which is 2. And then I have product of powers. I keep the base the same, which is g. And there's nothing here, so of course you know that's a 1. And 1 plus 27 is 28. So your answer would be 2g to the 28th power. Example number 4 is just really product of a powers, but I didn't show you this in the last video, so I wanted to show you it now. You have some coefficients, so you're going to multiply those first. Negative 2 times 8, which is negative 16. You keep the base the same, which is p, and then you add, be careful because you're multiplying, but you add 3 plus 4, which is 7. So it'd be negative 16p to the 7th power. My last example I want to point out has a fraction in it, which kind of changes things just a little bit, and it really just changes how you write them up. So this is really 5/6 times q to the 4th all to the 3rd. It has a power of a power, not really a product of a power because I have no variable here. So let's do this power of a power first. So I keep the base the same, and I multiply 4 times 3, which is 12. And then I'm going to multiply that by 5/6. So again, you're kind of multiplying these numbers. It's 5/6 times 1. So 5/6 times 1 is 5/6. And then I have nothing to combine q to the 12th with, so I just bring q to the 12th. Now, over. You have to be careful because technically this is right, but it kind of is deceiving how it's written. When you have a fraction, this is really like 5/6 and q to the 12th over 1. So if I think about this and I multiply the numerator, I have 5q to the 12th. And then if I multiply the denominator, I have 6 times 1, which is 6. Now that's probably the best way to write it. And I really want you guys to push yourself to write it in this format because it's going to make a difference later when they get more complicated. So the best way to write this would be 5q to the 12th all over 6.